On 18, when you divide like bases, you keep the base and you subtract the exponents. So 5 to the 4th divided by 5 squared, you keep the 5, you subtract 4 minus 2. 3 cubed divided by 3 squared, you keep the 3, you subtract 3 minus 2. So you end up with 5 squared times 3 to the 1st. 5 squared, 5 times 5 is 25. 3 to the 1st is just 3. 25 times 3, the answer is 75. When you divide things that are in scientific notation, you can split it up to where you're just doing the 4.7 divided by the 9.4, because those are alike. And then you can divide the tens. So 10 to the negative third divided by 10 to the positive third. Well, 4.7 divided by 9.4 is 0.5. Then you keep the 10 and you subtract the exponents. So you do negative 3 minus 3. So you end up with 0.5 times 10 to the negative 6th. But that is not in scientific notation. So what you do is you multiply your 0.5 by 10 so that you get 5. But then to keep that balanced, you have to divide the other side by 10 to the first. So then you're going to keep the 10 and you're going to do negative 6 minus 1. So you end up with 5 times 10 to the negative 7th. Number 20, you're multiplying all those a's together, so you keep the a and you add the exponents. So 5 plus 0 plus negative 5. Well, 5 minus 5 is 0, 0 plus 0 is 0. Anything to the 0 power is equal to 1. 26, when you have a power of a power, you multiply the exponents. So you're going to do b to the 4 times 6 times b to the first. 4 times 6 is 24. And now, if you have b times b, you keep the b and you add 24 plus 1. So you end up with b to the 25th power. If you want to find the value of each power of 10 and you have 10 to the negative 12th, I just think of it as 1 times 10 to the negative 12th. So I know that my decimal is behind my 1, and then I have to move it 12 places to the left. I can move it once to get in front of the 1, and then I need 11 zeros. And then my decimal point. So I have a decimal point, 11 zeros, and then a 1. If I wanted to write this number in scientific notation, I've got to get it to be a number between 1 and 10. So basically I'm moving the decimal in between the 7s. So I'd end up with 7.7 times 10, and then you count how many places you move the decimal. So 1, 2, 3, 4, 5. So you got to decide, is that going to be a positive 5 or a negative 5? Since that's a small number, that's going to be negative 5. On number 57, anything that has a negative exponent gets flipped. So the h cubed can stay where it's at. The k has to go down to the bottom. And then I have 6m squared. So if I just put this in alphabetical order, I'd have h cubed on top and then 6km squared on bottom. On number 46, I'm solving this by substitution. Y is already by itself, so I just have to take the x minus 1 and plug it in where y is in the other equation. And I write x plus x minus 1 equals 10. So 2x minus 1 equals 10. So add 1 to each side. 2x equals 11. Divide by 2, and I get x to equal 5.5. Then plug your x in. I'm going to go back into the top equation and say y equals 5.5 minus 1. So y is going to be 4.5. So if I put it in an ordered pair form, it's 5.5, comma 4.5.